Hello everyone, welcome back to my channel. In today's video, we're going to learn about pH, one of the most important parameters in water testing. Let's understand what pH is, how it's measured, and why it matters in maintaining water quality. pH stands for the potential of hydrogen. It is a measure of how acidic or basic a solution is. In simple words, it tells us whether the water is sour like lemon juice or bitter like soap. The pH value depends on the concentration of hydrogen ions present in water. The pH scale ranges from 0 to 14. A pH of 7 is neutral, which means the water is pure and neither acidic nor basic. When the pH is less than 7, it is considered acidic, meaning there are more hydrogen ions, for example, lemon juice or vinegar. When the pH is greater than 7, it is considered basic or alkaline, which means fewer hydrogen ions, like soap or baking soda. For example, stomach acid has a pH around 2, which makes it a strong acid. Black coffee has a pH of about 5, which is a weak acid. Pure water has a neutral pH of 7. Baking soda is a weak base with a pH around 9, and bleach is a strong base with a pH close to 13. Understanding pH is very important in water testing because it affects the taste, quality, and safety of drinking water. In water testing, measuring pH is one of the most important steps because it tells us whether the water is acidic, neutral, or alkaline. The ideal pH for drinking water should be between 6.5 and 8.5, as recommended by the World Health Organization and other quality standards. If the pH value falls outside this range, the water may become unsafe for drinking or damage pipelines and equipment. Chemists test pH in water for several reasons. The first is drinking water safety, because pH affects the taste of water, the corrosion of pipes, and even the effectiveness of disinfectants such as chlorine. The second reason is wastewater control. Industries produce wastewater that may be too acidic or too alkaline, and chemists ensure it is neutralized before being released into the environment. The third reason is environmental monitoring. Changes in pH can harm aquatic life such as fish, and also affect plants and ecosystem. That's why maintaining the correct pH level is very important in water testing. It helps protect human health, industrial systems, and the environment. In the laboratory, pH is mainly measured using a pH meter, which provides a digital and highly accurate reading. For quick field testing, chemists may use pH paper or indicator solutions, but these are less accurate. Before every test, it is very important to calibrate the pH meter using standard buffer solutions, usually with pH values of 4, 7, and 10, to ensure accuracy. When interpreting pH results, water with a low pH below 6.5 is considered acidic, which can cause corrosion in pipes and give a sour taste. Water with a neutral pH around 7 is safe and ideal for drinking. Water with a high pH above 8.5 is alkaline, which can cause a bitter taste and scaling inside pipes. A chemist's responsibility is to perform accurate pH measurement and to record and report the results according to ISO and quality standards. They must also make sure that the pH meter is properly cleaned, calibrated, and maintained. If the pH is found to be outside the safe range, the chemist should recommend corrective actions such as neutralization or treatment. In summary, pH testing is one of the most basic yet most important tasks for a water chemist. It helps ensure that the water is safe, non-corrosive, and environmentally compliant. Thank you for watching. I hope you understood the importance of pH in water testing. Don't forget to like, share, and subscribe for more chemistry-related videos.